So in the last couple of videos, we built up the disk approach for calculating 3D volumes. In this video, we're going to take a look at a new method called the washer method. So let's get right into it. Let's take a look at this problem. So same old, we want to rotate the area, the region, bounded by these curves about the x-axis. So let's graph these curves. So I have my standard y is equal to x cubed graph. And of course my y is equal to x line. And I can't forget this statement right here. So apparently I only care about the x's that are greater than or equal to 0. So this is going to be the region that they want, not this stuff over here, because that is in the negative x region. And I want to rotate this area around the x-axis. Alright, so how would that look? This weird hollow cone. So here's our x cubed. Here's our y is equal to x. So notice that I can't envision this volume being made up of a bunch of these tiny disks like we're used to. It's because there's no material here. It's not solid material, it's a hollow cavity. Nothing is there. We only have solid material basically here and here. Only those parts of the disk. So we can't visualize this volume as being just a bunch of disks added up together, put on top of each other, like we have in the past. So what we do is that we envision this hollow volume as being made up of a whole bunch of these shapes right here. These are washers. These things. Maybe you've seen them before. Just don't think washing machines. These are engineering washers. And we can do that. Notice that here is our y is equal to x cubed curve. And here is our y is equal to x curve. So, we use washer method if our 3D shape volume can be visualized as a bunch of these washer shapes stacked on each other, but not a bunch of disks stacked up on each other. This is the washer approach. So, how do I form one of these washers? Well, it's not too bad actually. A washer is made up of two disks. We have the area of a bigger disk, and what we do is we subtract off of that the area of a smaller disk. And then we just proceed as we usually would with the disk method. A washer is simply two disks subtracted. So let's form the outer disk of this washer first. So if I look at it, radii produced by the y is equal to x curve will produce larger circles, larger disk areas. Here we go, radii, radii, radii. Those radii are y coordinates, so I need an equation that gives me those y coordinates. That's simply x, because I plug in an x and literally out comes the y. So this equation gives me the r's. I want to square each one of these r's and times it by pi. And by doing so, now when I plug in an x into this equation, I get the circular area of each one of these blue disks. And these are the bigger disks. Now their smaller disks will be produced by the y is equal to x cubed. If I take this r right here, pi r squared, it'll get me this smaller disk cutout. Alright, so I need to take each one of these R's right here. Each one of those R's is simply the y coordinate of that green line. What's an equation that gives me those y coordinates? X cubed. Alright, so this gives me the R of each green disk area. I need to square each one, times it by pi. And now all I have to do to complete my washer area is to take my bigger disk, the outer one, and subtract off of it the smaller disk, the inner one. And by doing this, I have formed the area of one of my washers. And of course, just like in the disk approach, volume is just the area of the base times some height. And it looks like this height is simply a little bit of distance in the x direction. So if I times this whole equation by dx, I get one of my completed small washer volumes. And of course my final step is just to add up all of these small washer volumes. Our first washer is going to be basically right here. That's at an x coordinate of 0, so x lower is 0, or x initial is equal to 0, whatever you want to call it. And our last washer is this one right here at x is equal to 1. So x upper is equal to 1. And I just have to punch out that math, and that will get me the volume of my target shape. Here it is without those washers, just so you can get a good look at it. So, washer method is really the same as the disks approach. But instead of forming one disk area, you have to form two disk areas. An outer disk area, the bigger one, and an inner disk area, the smaller one. And you got to subtract them to form a washer area, which then of course you can multiply by some height, dx dy, to make it into a washer volume, which you can then just add up. So, I mean, this washer approach is really the same as disk approach, but this is just the main difference right there at this step. And as a result, a lot of books and teachers will present the washer method as one of these two equations. This guy here is going to be your outer disk area, and RO here means the radius of the outer radius. And here's my inner disk area, and RI is the inner radius that produces that inner disk area. Of course, you'll have the dx form of this integral, in which these r's are functions of x's. You know, those are equations that we're all used to. Y is equal to x squared, y is equal to radical x. But of course, you have the exact same idea, but the dy form, in which these radii here are functions of y. Things like x is equal to sine of y, or x is equal to radical y, or something like this. But again, the way I teach is, I don't want to throw this just right at you guys. I mean, this is a lot to digest all at once. So I just really teach taking it slow and taking it step by step and just really realizing the concepts and the shapes associated with each one of those steps. If you slow it down and focus on each step, you can't go wrong. And just be careful, because all of the stuff that makes disk problems hard, I mean rotating about the y-axis or any vertical axis or any horizontal axis for that matter, all those traps are going to be in washer problems too, because washer problems are really just two disk problems. So just watch out for all that. But that is it for the washer method. If you want some practice using this method, I'll have a video in which we go through some practice problems.